last time we talked about stacks, so today we'll talk about queues. So first, what is a queue? A queue is a linear data structure that is open at both ends, and the operations are performed in first in, first out order. So last time we talked about first in, last out order. So this means that the first one that is put into the stack will be taken out at the last. So we define a queue to be a list in which all additions to the list are made at one end and all deletions from the list are made at the other end. So the element which is first pushed into the order delete operation is first performed on that. So this is contrast to the first in last out principle of queue. So it is called the first in first out principle. So a queue is like a line waiting to purchase tickets, where the first person in the line is the first person served. Position of the entry in a queue ready to be served, that is the first entry that will be removed from the queue. So this is called the front of the queue, sometimes the head of the queue. So we can see it here. This is the front of the queue. Okay, so similarly, the position of the last entry in the queue, that is the one most recently added, is called the rear or the tail of the queue. So you can see this picture. This is the front and this is the rear. So now I will talk about several types of queues. So the first one is called circular queue. So circular queue is a linear data structure in which the operations are performed based on first in, first out principle, and the last position is connected back to the first position to make a circle. It is also called ring buffer. This queue is primarily used in the following cases. The first is memory management. So the unused memory locations in the case of ordinary queues can be utilized in circular queues. And the second application is the traffic system. So in a computer-controlled traffic system, circular queues are used to switch on the traffic lights one by one repeatedly as per the time set. The third one is CPU scheduling. So operating systems often maintain a queue of processes that are ready to execute or that are waiting for a particular event to occur. So the second commonly used one is input restricted queue. So in this type of queue, the input can be taken from one side only, rear, and the deletion of elements can be done from both sides. This kind of queue does not follow the first in, first out. So this queue is used in cases where the consumption of the data needs to be in FIFO order, but if there is a need to remove the recently inserted data for some reason, and one such case can be irrelevant data, performance issue, etc. So the advantages of the input restricted queue are, so first, it prevents overflow and overloading of the queue by limiting the number of items added, and it helps maintain stability and predictable performance of the system. And the disadvantages are, so it may lead to resource wastage if restriction is set too low and items are frequently discarded. And it may also lead to waiting or blocking if the restriction is set too high and the queue is full, preventing new items from being added. So another type is the output restricted queue. So in this type of queue, the input can be taken from both sides, rear and front, and the deletion of the element can be done from only one side, so it is the front. The queue is used in the case where the inputs have some priority order to be executed, and the input can be placed even in the first place so that it is executed first. So now we want to make sure that we all understand the concept of first in, first out. So Now, maybe I'll give you an example. Okay. So assume that we have a queue here. So if we push the elements, for example, 4 characters, which are Tony, T-O, and Y, so these 4 characters are pushed into the queue. So if you want to pop them out one by one, so what will you get? So Tony, you can answer this question.
Y. Y and O T.
No, I said it is Q. So it is.
T O and Y.
Yes, so the T is the first one that is pushed into the Q, so it will be placed here. And then it will be O and Y. And then the first one that is pushed into the Q will be the first one to be popped out of the Q. So the T will be the first one out, and then it's O and Y. Okay. So now I'll talk about priority queue. So this kind of queue is also very commonly used, and later probably we'll also talk about this queue when we are solving with algorithms. So a priority queue is a special type of queue in which each element is associated with a priority and is served according to its priority. There are 2 types of priority queues. The first is the ascending priority queue. So element can be inserted arbitrarily, but only smallest element can be removed. So for example, suppose there is an array having elements 4, 2, and 8 in the same order. So while inserting the elements, the insertion will be in the same sequence, but while deleting, the order will be 2, 4, and 8. So the second is called descending priority queue. So element can be inserted arbitrarily, but only the largest element can be removed first from the given queue. So for example, suppose there is an array having elements 4 to 8 in the same order. So while inserting these elements, the insertion will be in the same sequence, but while deleting, the order will be 8, 4, and 2. So now we'll talk about the applications of a queue. So the first is multi-programming. So multi-programming means when multiple programs are running in the main memory. It is essential to organize these multiple programs, and these multiple programs are organized as queues. The second is network. In a network, a queue is used in devices such as a router or a switch. Another application of a queue is a mail queue, which is a directory that stores data and controls files for mail messages. And the third is job scheduling. So the computer has a task to execute a particular number of jobs that are scheduled to be executed one after another. These jobs are assigned to the processor one by one, which is organized using a queue. So the last is shared resources. So queues are used as waiting lists for a single shared resource. Okay, and here are some real-time applications of a queue. So the first is ATM boost line, and also ticket counter line and key press sequence on keyboard or CPU task, scheduling or waiting time of each consumer at call centers. So it is very easy to understand that all the queues in real time are applications of a queue data structure, and all the applications that requires you to assign the order of probably the task is also implemented by, it also implements a queue to finish the task. So here are some advantages of a queue. So a large amount of data can be managed efficiently with ease, and operations such as insertion and deletion can be performed with ease as it follows the first in, first out rule. And queues are useful when a particular service is used by multiple consumers. Queues are also fast in speed for data inter-process communication. And queues can also be used in the implementation of other data structures. So here are also some disadvantages of queues. The operations such as insertion and deletion of elements from the middle of the queue are time consuming because you need to first delete or pop out all the elements that are in front of this element. So for example, if you want to delete the n from the queue, so you need to delete these elements before you can pop out this element. Okay, so the space is also limited, and in a classical queue, a new element can only be inserted when the existing elements are deleted from the queue. So this means that if the queue is full, you need to delete element from it. So you cannot add size to this queue if it is a classical queue. And searching an element also takes O(n) time because you need to traverse through the whole queue if you want to find an element. And the maximum size of queue must be defined prior. So this also means that if you have a queue, you want to define queue, you must first predefine its size. And if you find that its size is not enough, you probably cannot add any size to it. Maybe you need to define a new one. Or maybe you can delete something from it, and then you can add new elements. Okay. So here are some common issues of a queue. So if you find that your queue has a problem when you're writing a code, probably these are the probable issues. So the first is queue overflow. It is very similar to the stack overflow problem. So queue overflow occurs when the queue reaches its maximum capacity. And the second issue is queue underflow. So this occurs when an attempt is made to remove an element from an empty queue. So this is also similar to the stack underflow. So if you want to remove an element from the queue or a stack, you must first write a if statement to check whether it is empty. And the third one is priority inversion. So priority inversion occurs in priority queues when a low priority task holds a resource that is high priority, a high priority task needs. So this can cause delays in processing and can impact system performance. And the last one is deadlocks. So deadlocks occur when multiple threads or processes are waiting for each other to release resources, resulting in a situation where none of the threads can proceed. This can happen when using concurrent queues and can lead to system crashes. And these are all today's activities, so thank you.